D's brother Dwayne works as a contractor. He charges a fee of $150 when he goes out, just for driving out, $150, and then he charges $20 for each hour he's there. What is the independent variable? Now, when you're thinking about independent variable, it's what everything depends on. So if you call a contractor to come do work, right, your total cost will depend on how long it takes them, right? If a contractor can do a job in 2 hours, it's going to cost you far less than if it takes him 2 weeks, right? So the independent variable, what it depends on, well, it depends on how many hours it takes. So we use X as our independent variable, and it represents the number of hours that this contractor is there. Now, the dependent variable, if you were listening to me talk, right, we usually use that for Y, is the total cost. Your total cost depends on how long he's there. All right, so what's the average rate of change? Well, the slope, or the average rate of change, is what happens over and over again at a constant. And if you think about this, you know, we're talking about numbers here. Flat fee of $150 happens one time. However, $20 for each hour. If you see that for each, that right there is your slope. So the average rate of change in this case is $20. I'm just going to go ahead and say 20 because it happens over and over again. Every hour he's there, $20 more. Another hour, $20. Another hour, $20. Right? Now the starting point is the 150. It's that one-time occurrence. What happens one time and then doesn't happen again? That is your starting point. So we call our slope is M. Our y-intercept is b. When you're looking at your model, y equals mx plus b. So in number 5, we're going to put those pieces together. So in those pieces, we have y equals slope times x plus the y-intercept. Because if you think about it, if you're there for 4 hours, let's go to number 6, if he's there for 4 hours, well, put this in here, how much will 4 hours cost somebody? Well, that's 80 plus 150. That means the average 4-hour call will cost $230. So in number 6 here, if the average call is 4 hours, which costs the customer $230, how many calls will Dwayne need to finish to do 700? Well, if his goal is 700, divide that into 230 because every 4-hour call is charging $230, and you're going to get like 3.04. Well, if you just say 3 calls, he's short by $10. So if he needs $700 for something, then you're going to round that up, and it's going to take him 4 calls to hit his $700 mark. All right, new example. Life expectancy at birth in the U.S. has increased at nearly a constant rate since 2005, when it was 77.3 years. In 2013, life expectancy was 78.8 years. Create a linear model representing life expectancy at birth in the U.S. from 05 to 13. Now, the big thing is that, remember, when you're talking about y-intercepts, the number that falls on here should have an x value of 0, because a y-intercept where it crosses the y-axis, and at the y-axis you have an x value of 0. Therefore, if we're going to start in 2005, that means for 2005 x equals 0. So we will have the ordered pair 0, 77.3 for 2005. Now, 2013 is 8 years later, so x is going to be 8. And I have the ordered pair 8, 78.8, because in 2013 it rose to 78.8. Right? So here's my 2 ordered pairs. Now, which one of these is the starting point? Well, it's the starting point when x equals 0. So 77.3, oops, that goes down here, is the y-intercept. Because when, in number 7, we start when x is 0. That is our y-intercept. So 77.3 is where our graph will cross the y-axis. Okay, we got to find the slope. Now, the slope is found by taking, if you recall, let me change colors since I'm changing concepts. Slope is change in the y values over the change in the x values. So remember, I'm going to put my ordered pairs down here. We have 0, 77.3, and 8, 78.8. So when I want to find my slope, I take, this is too small for me, so I'm going to take my y value, 78.8, and I'm going to subtract 77.3 over 8 minus 0. Notice these numbers create this ordered pair. So you always want to make sure that your ordered pairs are on top of each other. All right, and then we subtract. So I get 1.5 over 8. And you can't, a slope generally is written as a fraction, so this is a perfect answer, but you could write it as 0.1875. This, because this slope comes out nicely as a decimal, you can change it to a decimal, but as a mathematician, I really prefer my slope to be written as a fraction, but that's personal preference. Now, number 11, because all of that blue writing is number 10, or is above number 11, using the slope we calculated in the starting point, construct a model. Remember, your model is y equals slope, and I'm going to use 0.1875 because it'll be easier in our equation to solve, times x, plus my y-intercept, which is 77.3. So this is our model if we want to use it for anything. So in number 12, we want to interpret the slope. Okay, well, let me rewrite the model just so that we have this here. X plus 77.3. Now, to interpret the slope, slope is positive. That means it increased because it increases positive, decreases negative. So it increased at a rate of 1.1875 per 1 year. And we're talking about life expectancy. So every year that passed between 2005 and 2008, you could expect to live 0.1875 more years, which is roughly a fifth of a year. It's an extra, what, 2 months, maybe month and a half, 2 months. So that's not bad. It's not bad. All right, let's go to number 13. It says, use your model to estimate life expectancy at birth in 2008. Well, remember that x equals 0 for 2005, right? So 2008 is 3 years later, so that means x is 3. So we're going to plug that in here. Y equals 0.1875 times 3 plus 77.3. So when I do that, I get 0.5625 plus 77.3. So my average life expectancy in 2008 would have been 77.86 years. And that is linear modeling.